Welcome back to a new tutorial on time series analysis and forecasting in R. This is tutorial number 3, where we are going to focus on analyzing the properties of our data. Specifically, we're going to check whether our series are stationary or not. Stationarity is a fundamental concept in time series forecasting because many of the models that we use, like ARIMA or VAR models, rely on this property to produce valid and reliable forecasts. My name is Juan D'Amico, I'm an economist, and on this channel, Forecasting Economics, I teach applied economic models step by step. So if that sounds interesting to you, please make sure to subscribe. It's free and it helps me to keep creating more educational content for everyone. For those of you who value the content and want to go a step further, I also offer some channel memberships with 2 different categories. One is just a simple way to support the channel, and the other one gives you exclusive access to more examples and advanced tutorials. So please feel free to join. You're going to find the link in the description of this video. So without further introduction, let's get into today's tutorial. We are going to be working still with our oil data. Remember, it was oil prices and real economic activity index. And in this particular case, we have already imported our data set and we have defined a time series object. We're going to start with a new script for this tutorial. I'm gonna call, let's just put a title here for reference. This is tutorial number 2. The first thing that we need to do is to import and install some packages. First, install packages. In this particular case, we're going to install. This is the command, you already guys know, install.packages. We open parentheses and in quotations, we're going to write T-series. This is for time series models. The next thing that we need to do is to load the library. So all you're going to do is library T-series. The next thing that I would like to do, let me run this line. I'm not going to run install packages line because I already installed this. So I'm gonna put here run only if you don't have it. Perfect. The first thing in Stationarity is looking at the plot of our data. So the command for that is plot, and we're going to plot our data. That's it. We're going to run this line, and here we get the graph, and right away what we can see is that oil prices seem to have a regular behavior, but starting probably after the 2000 we see that it starts to go up and is showing some upward trends, going down, up again and down. But the idea of this is that our series is not wiggling consistently around the mean value. This series to me looks a bit better. Looks like this index has a more stationary look than this one in particular that starts this way and then goes up, down, up. Ideally, our series will look like this. It's gonna look up and down, up and down, up and down, up and down. Like it will wiggle in a consistent way around the mean value. If we make a line here, we can see that a moment goes up, down, up and down. But when we see a clear trend, then we are in the presence of a series that is non-stationary. One of the things that we may want to do as well is to proceed with autocorrelation, an autocorrelation graph. So let's put here a title, plot the data. The next thing is going to be autocorrelation. The code for this is going to be ACF. That's the autocorrelation function. And then we are using this on our data. And in particular, I want to focus on this tutorial about oil. The first element, I leave it empty. The second element is the column that we want to keep. I only care about oil. Yeah, we close brackets here, that's fine. And then the last thing that we have to do is, if we want, we can just put a title, ACF, and let's say oil. That's fine. Let's run this, let's see what we get. And here the autocorrelation of our series. You can see right away that the autocorrelation decays in a very slow way, in a very slow pattern. So this is a clear indicator that our series is non-stationary. In an autocorrelation function that is stationary, you're going to see that you're going to find that the decay is immediate, or again, it's going to have a very inconsistent pattern, but you're not going to see something where the decay is so slow, because this is basically saying that this is basically suggesting that our series is non-stationary. Another thing that you may want to look at is the partial autocorrelation. The code for this is PACF. The idea is all the same. It's on our time series data. I only care about oil for this tutorial. We're going to be looking at oil prices. Just to make the tutorial shorter, let's put a title. Let's put PACF oil prices. We can run this line, and here we see what are the significant spikes in our data, and we clearly have this first autocorrelation here is very significant, and it seems to have a second autocorrelation as well. So this, like I said, all these things are already suggesting we don't even need to do really too much analysis when you see data that has such a strong look as a trend like that. You already can sense that things are not going to look ideal. But still, this is part of our formal analysis. We can continue with, for example, the Augment Dickey test. In this particular case, the command, you have it here, it belongs to the time series library that we have imported. You have here, of course, the syntax. All right, so these are some of the things that you can play around with. Let's begin then with the definition. In this particular case, we're going to be using on our data. In particular, we already know where we want to look at our oil data set, at our oil variable, sorry. By now, I think you guys are getting very familiar with how we are working with the commands. I think for those of you who already follow my channel are very familiar already with the writing, with the syntax. So I think you guys are all going to be able to handle this perfectly. So let's run this. Here we have the results. We see the title, Augment Dickey test. We have the statistic. We have the lag order, the p-value, and what is the alternative hypothesis that the series is stationary. Let's not focus too much on the alternative hypothesis because it can be confusing. I'm gonna write here for you guys that the null hypothesis is that the series has a unit root, which means that the series is non-stationary. Okay, and if the p-value, I'm gonna write here, if p-value is bigger than 0.05, we cannot reject the null hypothesis. So in this particular case, we see that the p-value is bigger than 0.05, so we cannot reject the null hypothesis that our series has a unit root and therefore is non-stationary. So I hope that this provides you a better understanding. Maybe this is less confusing. I don't like to think too much about alternative hypotheses because it can be a bit confusing. Let's proceed now. I'm going to show you another test. In this particular case is the KPSS test. I'm not gonna pronounce the name of these guys because it's very difficult, especially when your Spanish accent doesn't help. But you can look at KPSS test. But the idea is that the KPSS test is going to flip the null hypothesis. In the Augment Dickey test, the null hypothesis is that our series is non-stationary. In KPSS test, the null hypothesis is that our series is stationary. Okay, so if we reject then the null hypothesis, we are in a scenario where our series has a unit root and therefore is non-stationary. So the command for this, you already know. We have to use it in our data. In particular, I want to use it on my variable oil. There we go, and that's about it. We can just run this line. And in this particular case, what we see is that we are rejecting our null hypothesis. The p-value is smaller than 0.05 here. Null hypothesis. Series is stationary. And here I put if p-value is smaller than 0.05, our series, we reject the null hypothesis, our series is non-stationary. Okay, so here we go. That's the explanation. So I hope this makes sense, guys, for you. But those are two formal tests that we guys can try when looking at the stationarity of our data. So okay, we have defined, looking at the graph, looking at the autocorrelation, looking at two different formal tests that our series is non-stationary. What are we going to do next? Normally what we do in economics is we try to convert this data, transform the data into a stationary series. In a particular case, the way we do this is by expressing our variables in terms of percentage change, in terms of growth rates. So to do that, the first thing that we're going to do is to apply logs. So all you're going to do is first create a new variable. Let's call it log oil, something very simple. The way you create a variable, remember these are the symbols. We are going to apply log to our data set. Which particular variable? You already know, oil. There we go. And that's about it, guys. We just run this line. We're going to generate now a new variable. You can see log oil that has these characteristics. Let's now go with the last step, which is applying differences. How are you going to apply differences? Well, we need to create a new variable. Let's just call it differences of oil. And what we need to do is to type diff and then what variable we want to apply differences to. Well, I want to apply differences to log of oil. One of the things that I like doing myself is multiplying these times 100. Why? Because it's going to show then my results. The variable is going to be in percentage. All right. So we have now our variable differences of oil, and the last thing we can do is I want to show you now the plot the series. We're going to type plot. You already know what variable, difference of oil. That's what I want to plot. And the title is oil prices. Let's just put in brackets percentage. So here I think we have everything properly. Let's run this. And now you can see, guys, the difference between a series that looks stationary that I mentioned to you guys before. It's going to wiggle consistently around the mean. You can see that this looks like a stationary series. It has a couple of outliers that we can look at. Then those are things that probably we can, in a model, if you guys want, you can include maybe a dummy variable to exclude a couple of the outliers, and then the series is just going to look very, very, very stationary without any sort of outliers. But let's go back to plotting now our data. In this particular case, TA's data. I want to show you how it looked like the variable. in levels. So let's type oil. You see the difference? How this has an upward trend, goes down, up, down. This is clearly something that is not stationary, but when we look at this series now, you get something that wheels consistently around the mean. So guys, I think this is going to be a really good place to stop with this tutorial. I have shown you some very key aspects of data analysis, in this particular case for stationarity. So that's going to be the tutorial for today. I hope this helped you understand why stationarity is such a key step in time series analysis. If you enjoyed the video, don't forget to like, comment, share it with others. It really helps guys to grow this channel and reach more people interested in applied economic models. Remember, if you would like to support the channel, you can also get access to extra examples and more advanced tutorials in my membership, so check, it's in the link of the description of the video. And visit my website, because you're going to find the data set and you're going to find the R code to download for free. So thank you very much for watching, and I'm going to see you in the next tutorial.